Hello guys, Happy New Year, and hopefully all of you guys made it alive, well and safe. So this is time to press on, especially for the new matriculants of 2025. But those of you who are coming from 2024 and are looking to upgrade your performance or your results, this is also the best time to look at this. And hopefully you have seen the previous video on the maths paper 2 for the same year 2024 finals. There I tried to highlight the summary of what exactly maths entails for school level. I can put it that way. So it helps, to kind of summarize things so that you put everything that's done into perspective rather than just a mere routine. Yes, we start with routines where we don't really understand much, but there has to come a time when we sum it all up so that it all makes sense. Because as we progress, we need to carry that knowledge forward. All right, so algebra, guys, is key, and it is the basis to a whole lot of advanced mathematics that you will later learn at university, colleges, where you start to realize that what you thought was difficult is nothing. But I can assure you, none of those things look very difficult if you understood the basis, which is, school level mathematics. Because when you get there, you've already understood and you already know what goes where. It becomes even easier. For me, I never found any difficulties when I had to apply maths. I mean, we only used applied maths because we did biophysics in med school. So biophysics, it's more of an equivalent of what you would call maths in some engineering studies, so to speak, because there's no major subject called mathematics in medical school. It's more of applied maths. But let's not go into the details of that. So what I'm trying to suggest is knowing algebra very well is very important because it forms the basis of all that you will do in your grade 12. So you need to be sharp and to be good. Okay, so let's just have a look at question 1 here just to show you some knowledge that needs to be settled by the time you do your matric. This is going to be a part of your term 1 exam, so be ready to get this done efficiently. So we've got question 1.1 with 1.1.1, and we are solving for x. So we have x into x minus 3 is equal to 0. Now, any algebraic expression, the approach is you inspect it first. Don't just rush. What do we see? What we see here is a quadratic that is factorized. And how is this factorization? Is by taking out the highest common factor. Okay, because the highest power here would be x squared. Great. So if we've got a product and it's equal to 0, it means each component of the product must be 0 for that whole product to eventually be 0. So we can just jump into conclusion and say x should be equal to 0 or x should be a 3. Obviously what we do is just take this equate to 0, we take this equate to 0, and then we solve. But now there's no need to show all of that step. It's not necessary. What matters is these solutions. Okay, but now how do we prove that these solutions are correct? Because remember, mistakes do okay. Pay attention to the original expression. I will just say ensure it's copied correctly. Because if this is not copied correctly, then this check won't work. So we take these solutions, we plug them into the original. We prove that the left-hand side becomes equal to the right-hand side. If we place 0 for x, we get 0 into 0 minus 3. So 0 times any number is 0. So this checks out. So that means the left-hand side is equal to the right-hand side. We put a 3 for x, so we will have 3 here. This is 3 minus 3. This becomes 0. 0 multiplied by any number gives us 0. So that checks out. So we know that these solutions are definitely correct. And that's how we get our first 2 marks. Very easy. So guys, be in the habit of checking those solutions every time you can, so that you don't miss out on easy marks. So we have the next expression, 2x squared plus 1 is equal to 4x. Okay, and we are told to solve correct to 2 decimal places. This is already suggesting that the roots in this quadratic are irrational. Of course, if this is not stated and you're not so sure, check the discriminant, b squared minus 4ac. And if this is not equal to some perfect square, then we know that we need the formula. Usually this is what gives a clue. So I would say, please note, the nature of roots we learn in grade 11 helps us. Sometimes this may not be volunteered, but someone may anchor the rounding off in terms of the general instruction, because remember, this still holds. So there's no need at times to say this. It may be said oftentimes, but sometimes it may not. You need to remember that. So at times in maths, we can do anything to examine a student. So first of all, when we solve this thing, writing it in standard form is important. 2x squared, we transpose this, it becomes minus 4x. We keep that, and we make the right hand side equal to 0. And obviously, having been given that instruction of rounding off to 2 decimal places, we already understand that we need the quadratic formula. Remember, what does the instruction say? The instruction says show clearly all calculations, diagrams, graphs, etc. The etc. covers a formula. So we can't just jump and substitute. We have to write the formula first. So understand instructions in terms of what is expected, because not doing so is losing a mark. It's a penalty for not adhering to instructions, as would be the case when you are driving on the road and you don't adhere to the instructions. Then you get a penalty, which is a ticket. So this is minus. Now, what do we substitute? We see b is the coefficient of x. So this is b. That's what we put in place for b. So this is minus into minus 4 plus or minus the square root minus 4 squared minus 4 into. Now what is a? A is the coefficient of the highest power. So my aunties are up and Palili message. It's fine. So this is what we're going to put here. So this is going to be a 2. Right? That's that 2 for A. And then C is the constant term. Remember, the signs go along with that. So that is what we put in there. So C comes in there. All right. Divide this. We divide this by 2 into 2. Again, we said that was A. So please, guys, make sure the substitutions are perfect, because this is a mark-worthy step. Yes, writing the formula is not much of a big deal, but we need to see that the formula correlates with what is done here. Okay, good. So even if the formula is written wrong up there, if the substitutions tie up with that formula, as wrong as it is, you get a mark for correct substitutions into the formula you have shown us. Okay, you don't lose that mark just because the formula is wrong, but obviously you lose the mark for the answer because the answers are going to be incorrect. Anyway, so at this stage, I do not waste time trying to simplify the discriminant, which is the term under the square root sign. So just a moment, guys. Okay, guys, I had to take care of some work-related issue here, just to make it nice and smooth so that we don't have problems. Okay, now I'm substituting into the calculator, Make sure the substitutions, guys, are correct. So what I'm getting here is 1,71 to 2 decimal places, or x is, let's see, we just go back to our original framework. We just change the sign to a negative where it's necessary, and then I am getting a 0,9, sorry, not 9 but 29 to 2 decimal places. Okay, so these are the solutions, and of course it's something we know we have done well, but remember, mistakes can occur. You can write those answers with confidence and yet they would be wrong. Now remember, guys, every solution we get, we must take it back to the original. So at times you may want to use the standard format because we didn't really manipulate, but remember, any manipulated expression, there may be a mistake in terms of signs. It always happens. So try to avoid checking that, provided the original statement or the original expression is written correctly and it's copied exactly as it is presented on the question paper. Now all we need to do is just to say 4 times x, which is 1,71. So this is 6,84. If we round off this to the nearest integer, it becomes 7. Okay, then we check again on the other side. We say 2 into 1,71 all squared plus 1. So this is rounded off to the nearest integer is 7. So it means the left hand side is equal to the right hand side. Only then we can accept that answer. You can do a check on this one as well. If it balances, we take that one. Remember, correct substitutions. When we say correct, everything has to be according to the formula and according to the expression. So that constitutes a correct substitution. And since this is algebra, it's more like arithmetic. So writing an expression in standard format may warrant an extra mark. So if we look at our mark allocation, it's 4 marks. So this is how we score those 4 marks, I suppose. Of course, you may want to look at the, what we call, the formal guidelines when they come out for a more clear and precise mark allocation. But remember, that depends on the examiner. I'm just giving you the standard approach to marking guidelines, okay? Here, we're not just presenting the memo, we are creating the memo, all right? So that you understand better. Now let's get to the next question, 1.1.3. What do we have? We've got x squared minus 2x minus 3 is greater than 0. Okay, this is a quadratic inequality, so we know we can factorize. So a means of solution here is factorization. So we have x, we can have minus 3 plus 1. Again, guys, be well versed with factorizations. Obviously, this is a quadratic expression. Like I said, you check the discriminant. If the discriminant is a perfect square, you know you can factorize, attempt to factorize. But if this is not coming out as a perfect square, provided everything is copied correctly and computed correctly, then it may be wonderful to try and use the quadratic formula. Remember, that is possible. It's not so common, but it can happen. Now from here, guys, I just draw a sketch. I never waste time with other methods that for me are not very, very, very strong. But it doesn't matter what is taught in class. For you, and you understand it well, use it. So this is how my graph should look like. Okay, of course, it's not exactly as nicely symmetrical as I want, but it gives the impression that I need to project. Now I know when I solve the critical value here, it's minus 1. The critical value there, it's 3. What would be the y-intercept is minus 3. And I know my axis of symmetry is in between these two. So this is going to be 4 divided by 2. That gives me 2. So my axis of symmetry is on the right portion of the x-axis, which is good. So a near perfect sketch is important so that you can read answers more appropriately, especially in applied sections like sequences and series. Here it doesn't really matter much, but try to do this so that every time a question is popped, you approach it with clear vision. Key is to understand what is before you. Rough sketches sometimes that are not really useful because they are not near accurate. They mislead a lot. You end up not knowing what needs to be done. Anyway, guys, so what can we see? We will appreciate that while these critical values are excluded, because the graph is at 0, it's grounded at 3, it's grounded at 1. So we put open circles because there's no equal sign there. And then we can see that if we go in this direction, the y values are positive. That is when this is greater than 0. And if we go in that direction, the y values are positive. Again, that is the greater than 0 part. In between, the y values are less than 0, so that's not included. So we leave that part. So usually you will find this shaded in this manner. Okay, sometimes you will find this shaded in this manner. All right, so this is essentially how we solve this. So you can make a conclusion that therefore x must be less than -1 or x must be greater than 3. Now in our curriculum we used to add this, that x must however be an element of all real numbers. I don't see this being said so often, and for me it's an important component of this answer. Without stating exactly what is x in terms of a set of certain numbers, it does not make sense to write what we write. So be very careful. Anyway, sometimes it's not really something that people pay attention much to. So we get a mark for each one of these solutions. And of course, whenever we factorize, we get a mark for that. For me, the third mark would be this. But again, to just write the domain, it's not a big deal. The extra mark could also come from a sketch, because remember, the instruction clearly said if we used a graph, we need to show it. If we used any means necessary, like a formula, we need to show it. Is it a law? Is it a reason? Something. We need to say exactly how we got to it. So this is very important, okay? Now, I would like to show you another technique, guys, that I think you need to master as well, so that you are well armed to deal with these questions, especially when we get to functions. Now, what I normally do, I take my binomial factors. Of course, from factorization, we can go this route. I put it on the table. So what we do, we just create a table there. It's called a table of signs in some texts. Sometimes we may want to call it an algebraic table. Sometimes I just don't know what is the correct, name for it. So we're doing a product because the brackets are multiplying. Critical values, we have -1 and 3. We list them in ascending order from left to right. Now what do? We say this first binomial factor, when will we get it to be 0? It's when x is -1. So zeros are important. We say what happens when we put a value between -1 and 3. Take 0 out of convenience, the answer is positive. Now what happens when we put exactly 3? It is positive. A value greater than 3, it remains positive. Now with a linear expression like this, if one side is positive and we have a 0, the other side should be negative. But again, do check by placing a value, say -2 plus 1, get a negative answer. Okay, we come to the next binomial factor. We ask the same question, when will it be 0? It's when x is equal to 3. Zeros are very important, we highlight. What happens when we put a value greater than 3? The answer is positive. What happens when we put an answer less than 3? I mean, obviously, this is a linear expression and we have a 0 on the positive side. This should be negative, negative, negative. But we can place 0 out of convenience for the part in between, get a -3. If we put a -1, we get a -4. We put a -2, we get a -5. So the answers are negative. Now what do we do? This is what will read our solutions. Now we say negative times negative, as those brackets multiply, this becomes positive. 0 multiplied by any number gives us 0. Positive multiplied by negative is negative. Positive times 0, any number multiplied by 0, 0 will dominate. Positive times positive, it's positive. Now to read our solutions, we know that at the critical values we get zeros here. So we put open circles because those are not included. And we can see we get a positive answer, which is a greater than 0 when we go in that direction and when we go in that direction. And of course we can compute the same answer, write the same answer, that x must be less than -1 or x must be greater than 3, where x is an element of real numbers. And that is the same solution as we have concluded. So remember, there are many ways of killing a cat. Just kill it, okay? So this is very important, guys. And I know this part is often ignored, but it is actually wrong to ignore it. It is a must. It's a part of the solution. We need to define the domain of our solutions here, even though we may have restrictions. All right, not a problem. I don't know why this thing keeps moving. Did I come here by any chance? Or maybe I did. Okay. Anyway, this is how we do this. We get a mark for this. We get a mark for everything. So this is 4 marks, guys. So remember, a tool may also be mark worthy. So that could be a mark. That's why I'm putting an asterisk, or it could be here doing the table, or it's on the solutions and provided with the domain. I don't know. It depends on the examiner. So don't lose marks by giving incomplete answers. Try to make sure those answers are complete. Okay, let's do the next one. So we have 1.1.4. So we've got x to the exponent 2x minus 2 to the exponent x plus 2 minus 32 equal to 0. As I often say, inspection, inspection, inspection. So we'll appreciate that we've got 2 to the exponent x here. That is seemingly very, very common. But now these are all exponential expressions, or we can call it an exponential quadratic equation. So what we do, we just say, okay, we can see that 2 to the exponent x is somewhat a common issue. We can put the 2 outside. This is minus 2. We split this. It's going to be 2 to the exponent x times 2 squared minus 32. This is 2 to the exponent 5, but we can leave it like that. Please try not to read this incorrectly and say 2 to the power x. That's incorrect. Or 2 to the power 2x. That's wrong. Okay, you don't say that. The index or the exponent is just the order in which this power is. This is more like the second order power of base 2, right? That's what it is if we think about it. Of course, this is also raised to essentially another exponent, which is x on its own. So we know the laws tell us that if we've got a particular power and it is itself raised to yet another power by a particular exponent, or in fact it makes a certain order power of that particular power as a base, therefore we simply just multiply the exponents to get the overall power. Okay, be very careful. When I say power, I'm not referring to the exponent. Do not make that mistake. People mince this a lot, even the best. So be very, very, very watchful. Anyway, however this is taught and however you feel it's right, it's up to you. Ne? It's not my problem. So this is 2 to the exponent x all squared minus. Now this is 4. We can simplify this. 4 times 2 to the exponent x minus 32 equal to 0. Now at this juncture, people who are scared of maths, or like some weak mathematics teachers and students, you'll be told of the K method. Okay, it's nothing fancy. It's just replacing something with K to simplify it. But this is really for weak students and for weak teachers to go around it. But, teachers who really want to teach maths and for you to deal with it as you see it, you have to see beyond just what you're seeing. If you can't see that, then you're already in trouble. But hey, whatever works or whatever rocks your boat, please rock it. For me, I know I can factorize here. Then I know this is going to be 2 to the exponent x, 2 to the exponent x, because when we multiply powers, meaning the power, the whole thing, with the same base, we simply add exponents. It goes back to the same. So this is minus, now factors of 32 is going to be 8 and 4. And I know if I say minus 8, I must say plus 4 there. This is fully factorized. This works out nicely. And then I say this implies that 2 to the exponent x is equal to minus 4. Now, there is never a power with a variable exponent that gives us a negative answer. So this is already wrong. So we cannot accept this. It's not real. You can even place logs. It will get an error. Or 2 to the exponent x is equal to 8. 2 to the exponent x is going to be 2 cubed. Remember, when something looks like this, can we express 8 as a power of base 2 so that it looks the same as this one? The answer is yes. 8 is a power of base 2 to exponent 3. Therefore, when we have powers side by side of an equation, of an equal sign, it means for this to be equal, therefore the exponents must be equal. Okay. Nice and easy. So this is our answer. So as I say, guys, when we deal with mathematical expressions, especially equations, we can find a way of proving our answers as true or not true. Now we just take this 3, we place it there. This is going to be 2 times 3, that's 6. 2 to the exponent 6 is 64. 64 minus 32 is 32. We put a 3 here, it's going to be a 5. 2 to the exponent 5, it's 32. Now we have 32 minus 32 is 0. So 0 is equal to 0. So this answer checks out. Please never leave these kinds of questions, especially equations, unchecked, because these are easy marks and you can be sure moving away from that question that it's done. You're not even interested in what the memo has to say. Okay, great. So that's a mark. And then, of course, guys, using laws. Remember laws, as I said in our summary, the 3-step approach, a law can be featured in the 3rd step. So whenever we do that, this is an exponential rule to split that situation. So we get a mark for this. And whenever we factorize, we know that is when we get a mark. And what else do we do now? How many marks are there? So this is 5 marks. Wow. Remember in algebra, when we reject certain answers, we get a mark. So how many marks do we have now? 1, 2, 3, 4. Where is the 5th mark? Obviously, to express this into an exponential form, from just a whole number to an exponential form. That is also using yet another law. So whenever we use the 3rd step, we get a mark. So folks, this is how I suppose these five marks are scored. Of course, this will depend on the actual memo, because the examiners can decide where the marks are. But I'm just showing you the standard approach, because if you pay attention to the standard approach of doing things, then even if your answer ends up wrong because of some mistakes, you will score marks from your steps. And of course, that could be guided by the marking guidelines if the approach proposed by the student is featured. If not featured, a maths expert has to be the one marking. This is why we can't take average maths teachers to go and mark our final examinations. It has to be only experts in the field, because they need to understand the student better than the memorandum, because the memo is created by someone who did not teach the students directly. So that person may be selfish in their solutions, or maybe even wrong at some point. So those teachers need to be able to see. So you can't have average novice teachers marking maths in the finals, even in the provinces. I still do not like the idea. But unfortunately, due to paucity of good teachers in the subject, we end up allowing people who should not be featured in this. As long as they have not been tried and tested by the best, they should not be there. But hey, this is South Africa, guys. Everyone is given a chance, even if they don't deserve it. Let's leave that to whatever it is. Sometimes overly politicizing things is not helping. Let's move on. So we've got a Z. So this is a quadratic in Z form. As you can appreciate, we have been doing quadratics. First, it's just the standard grade 7 or grade 9. Not grade 7, but grade 9. Grade 8 and 9, so to speak. Mainly grade 9. We factorize by taking the highest common factor. Usually this would be that in grade 10 where we factorize maybe by doing the bracket method or long division, whatever you call it. But since this is irrational, we then use a grade 11 technique because we are taught the general quadratic formula in grade 11 and we solve it. This is an inequality, but again, the major part of it is quadratic. Can you see the bracket method? This is taught in grade 10, essentially. And the rest is grade 11, okay? And we see that we have exponential expressions, again, grade 11 mainly. We just went about it. Now, you see, we're still dealing with a quadratic, but this time in Z form. Sometimes it's called radicals. Okay, this is the original, so please make sure it's copied correctly. So what do? The procedure is we transpose everything so that we isolate the square root. So this is minus 2x plus 4 is equal to x plus 2. Now the gymnastic of choice is to square both sides. This would imply that this is minus 2x plus 4 equals, this is x squared plus 4x plus 4. Again, to know the FOIL method or the distributive law must be second nature. It is taught in grade 10, guys, so do not come with stories here, even in grade 9 these days. So we write our quadratic in standard format because we can see the highest power here is x squared. So we do this in descending order of those powers. So we say this is x squared. Now 4x, when we bring in the 2, it becomes 6x, okay? And then the 4's cancel because they are the same sign on either side of the equation. So this is it, guys. So maybe I want to move this one closer. Of course, I was taught that my equal signs must not drift much. You must almost always draw a straight line across them, okay? Just for neatness sakes, really nothing fancy. Again, how do we factorize here? Because we want to solve, we take out the highest common factor, which is x. What we remain with is x plus 6 equal to 0. And when we've got that product, we know that x is 0 or x is going to be minus 6. Now we check our solutions as always. Now, if this is a habit, no one needs any second invitation in this regard. So we just do it. We put a 0 there in the original. Make sure it's copied correctly. This is going to be 0. Therefore, it's the square root of 4, which is 2. Now, this is essentially 0. So 2 minus 0 is 2. So 2 is equal to 2. So this solution holds. The left-hand side is equal to the right-hand side. And under the square root sign, we don't have a negative. We check minus 6. This is going to be 12. Plus 4, that's 16. Square root of 16 is 4. Now, we put a minus 6 there. This becomes a plus 6. So we've got 4 plus 6, that's 10. 10 is definitely not equal to 2. So we reject this solution. Just strike it like that. Or some people write invalid, some people write inadmissible, some people write not applicable. However, you are taught to reject this, but the mathematical way is just to strike that. And that's it. We are done. Very easy, as long as we know what we're doing. Of course, guys, this is algebra, the gymnastic. We get a mark even for rejecting that solution. It's a mark. Whenever we factorize, it's part of the 3-step approach. That is mark worthy, and that's how you get the marks. And if you apply this very well in a very sane way, you will know that, guys, that thing is also directory. It certainly gives you the right way to go around the solutions rather than to go in circles and wander in the wilderness there and never find your way back. How many marks are we scoring here? 4. So we've got 1, 2, 3, 4 marks. So we have them nice and easy. Okay, great. So let's move on, guys, before I lose too much time. I'm too relaxed now. 1.2. Now, guys, simultaneous equations are key, especially in applied maths, or when we apply the theory of algebra in some areas like functions, sequences, and series in the higher order questions. I can assure you, almost 80% of the so-called higher order questions, or the difficult questions, the multi-step questions, they will involve simultaneous equations. Of course, in paper 1, question 1, these are volunteered for the student to work with. But in those sections, one has to find the equations that are relevant, meaning derive those equations however that is possible, and then use these smartly and get to the answers. So this is a very important topic. Analytical geometry, trigonometry, Euclidean geometry, this applies heavily. So please be in a way of seeing this right now. So we have 2x plus y is equal to 3, which implies that y is equal to minus 2x plus 3. That we make equation 1, and we are given, what is this? This is y squared plus xy equals 2. This is some sort of an ellipsoid. You'll learn this in college if you go to college or university. So this can make equation 2. Now our job is just to put 1 into 2. So this is going to be, where we see y, we put minus 2x plus 3 all squared, plus x into, where we see y, we put minus 2x plus 3 equals 2. Remember, there has to be a correct substitution. Please, this is a very important step. It's mark worthy. So what do? We fold this out, we get 4x squared. This is going to be minus 6 by 2. This is minus 12x. Then that's plus 9. Plus, okay, not plus, but minus. X into this is going to give minus 2x squared plus 3x. We can transpose this 2 to make this a nice quadratic in standard format. This implies, now we deal with these like terms, 4x minus 2x, it gives us 2x squared. Then minus 12 plus 3 gives us minus 9x. And then 9 minus 2 gives us 7 equal to 0. Of course, to avoid my signs drifting too much, I can bring it here. But of course, guys, there's no need to do this, but it just makes everything easy to see. Now, we are almost always going to succeed in factorizing this thing. But if you're not sure, check the discriminant. So this is 2x, x. And then 7 is going to be minus 7 and minus 1. That's a big mistake. We can't combine 7 and 2. So we must put 1 there and 7 there. Nice. So this becomes minus 7x minus 2x, it's minus 9. That gives us plus 7. That gives us 2x squared. So we can simply say that x is going to be 7 over 2, or x is equal to 1. That would also mean y. If we take this and substitute into equation 1, this is going to be minus 2 into 7 over 2 plus 3, or y is going to be minus 2 into 1 plus 3. Now what do we get? The 2's will do the thing. So this is minus 7 plus 3. This is minus 4. This is minus 2 plus 3. That's 1. Okay, so that's it, guys. So we are good. Remember the original expression. This is the easiest, the linear, but we can still use that one. It's still original. We did not manipulate it. We check this set of values. We put a 7 over 2 for x. That becomes, the 2's cancel, we have a 7. For y we put a minus 4. So 7 minus 4 is 3. So 3 is equal to 3. So these solutions check out. Then we take the set, we plug it there. This is 2 into 1, that's 2. Plus 1, that's 3. So 3 is equal to 3. So those solutions work out, provided this is copied correctly. If at all it's manipulated and it's manipulated incorrectly, the answers will tie up and you will cry. Okay? Be very careful. So this is how we get the 4 marks nicely. And then the 5th mark is here. The correct substitution. It has to be correct, guys. If it is not correct, we die a slow death. Okay? Not a problem. Let's move on to the last question. So 1.3. I'm in papela. Damn it. Now 1.3, it's one of those higher grade questions, guys, where some knowledge beyond metric is necessary. You know, this is unfortunately a question that I doubt grade 11s can handle as it is, because it's a bit of a naughty question, to be honest. But grade 12s should be able to handle this question at the end of their term 1. Definitely they should. Now, let's get to this question nicely, because it's not a big deal, but it's one of those questions that may be very difficult because it tests more than what is shown. So one has to have a proper understanding of algebraic expressions and what it means. Because these long, lengthy ones where they continue and you don't know where they end, you just want to cry. Be like, how on earth am I going to deal with this? Because we're so used to finite situations. What about infinite situations? How could we narrow them down to something finite? Well, let's have a look. We're told to consider this product of 1 plus a half, 1 plus a third, 1 plus a quarter, and this pattern continues. Now, this is a clue, guys. Each factor in the product is in this form, 1 plus 1 over n. As we can see, n is variable. But what we can notice is that from 2 we went to 3, from 3 we went to 4. So this means this adds 1. So it's sort of like the denominators of the second term are increasing in an arithmetic fashion. That would be the common difference is essentially 1. So if you have the knowledge of sequences and series, then this becomes easy to recognize. So I'll say knowledge of sequences and series is important. Of course, the way they are taught in the lower grades, like grade 11 lately, I mean, we didn't really get taught these at that time. They were strictly grade 12 material. Although we did look at some sequences, but it was more of just looking at them by inspection, okay? Never was really to the detail that we get to do in grade 12. So I would suppose, guys, now things have changed a bit. Sometimes everything is a bit out of place. Unfortunately, this is just how the curriculum is designed. For me, it's designed to fail rather than win, because you can't just put things wherever you like. There are certain steps that should not be jumped so that people can have the proper use of these things once everything is put together. Anyway, it's just me. Let's just go on. So this is what we have. And we are given further that n must be either 2 or a value greater than 2. But nobody is telling us what n is. Is n an element of natural numbers, for example, or is it real numbers? We don't know. So this is a big question mark. But what we noticed is that from 2 to 3, we just added 1. And this is natural numbers, because natural numbers are a set of all numbers where the common difference is 1. So we can see that, okay, it's not really real numbers. So guys, I'm just showing you how to work out things. Now we know that n must be an element of natural numbers, because the pattern already gave us this. In fact, this is a clue, guys. Even if it was not included, in fact, for me, I would not include this. I'll just write what is going on here and say determine all the values of n for which the product would be an integer value. Okay, maybe that would be unfair. Yeah, it would be unfair, because we can't talk about n when we don't see n. Okay, maybe I would not even say this pattern, but I'll just probably write this term as the last one there and let you sweat. Okay, I'll just put it up there and let you sweat. But hey, sometimes examiners have different sets of skills that they're testing. So we're told here we want n to be an integer. Now integer, it's a natural number, right? Because if this is greater than or equal to 2, this is already positive integers, and positive integers, they make up a set of natural numbers. Okay, so now we know. Remember, can you see, guys, when you analyze, you look at things, you find out what they stand for. You start to have some understanding. Now let's write this product. So we've got 1 plus a half multiplied to 1 plus a third multiplied by 1 plus a fourth or a quarter. And then we are told this continues. But now, if this is the pattern, we know that the one preceding the last term here, it's going to be 1 plus 1 over n minus 1 into 1 plus 1 over n. That would be the end of it. So, can you see, this is the part that is missing. The examiner didn't give you this deliberately, because again, this is another way of checking if you understand your work. And as we know, this is the knowledge we get from sequences and series. So a new matriculant might be lost. What is going on here? You will learn as we deal with sequences and series. And of course, I'll try to give you guys some lessons on that. Fine. Now that we know what we are doing, we can say, fine, this is equal to. Now, remember the three-step approach kicks in. Once we have this set up, we go for the three-step approach. We see brackets, BODMAS. We always try to handle brackets, but we need to simplify what is inside first. So we know that if we multiply 2 there, it's going to be 2 plus 1, that's a 3 over 2. Now, you can even go about it the long route and say this is 1 over 1 plus 1 over 2, and then you find the common denominator, which is the multiple between those two. This is 2. 2 divided by 1 is 2. 2 times the numerator is 2 plus 2 divided by 2 is 1. 1 times the numerator is 1. And then we simplify, this is 3 over 2. So you can go about it the long route, but in metric, guys, you must also have some shorthand techniques, because trust me, you will cry if you have this always the crude way. That means you have not learned anything in your past 11 years. Now we do the same here. 3 multiplied there, that's 3 plus 1, that's 4 over 3. Okay? Or you can just put it in the calculator. I mean, nobody said don't use a calculator. So multiply 4 there plus 1, that's 5 over 4. Okay? And then this continues. We simplify this. We multiply by this. It's going to be n minus 1 plus 1. The 1's cancel. So we get n over n minus 1 into. Multiply by n in there. This is going to be n plus 1, which is n plus 1 divided by n. And that's how we simplify this. We have not done the BODMAS yet. We're just working with those complex terms. Now, what do we do next, guys? We will notice that, wow. Now, this is a product. When you then multiply these to this thing, so this means this 5 is going to take something down there. Somehow, it's going to go. Because the pattern continues the same way. And as you can appreciate, n takes this. And that means this one would be taken by something up there. Now, this is a logical thing. What you see in the middle here is the logical thing. So you need to logically appreciate that. If you don't, too bad for you, okay? So everything else goes. So this is nothing but just 1. Now the numerators multiply each other. We end up with n plus 1 divided by. Now everything is 1 except that, so it's just 2. Now this is the expression we end up with. Then we ask ourselves, we said n values must give us an integer. The product must be an integer. And we can see this product is this fraction. Now for this to be an integer, it means the numerator must be a multiple of 2. This thing must be a multiple of 2. So how do we deal with this? We can see this is an even number. So obviously for this to be even, 1 is an odd number. So guys, there's a lot of inspection that needs to go on in here. We know that 1 is an odd number already. So what must we add to an odd number so that we can get an even number? And we know that if we add 2 odd numbers, they will give us an even number. And an even number is divisible by 2. And therefore that would give us an integer. So this means if this is odd, then n must also be an odd number. But now 2 is not an odd number. But anyway, we're told that this has to be 2 or greater than 2. So if it cannot be 2, because 2 is an even number already, and if we say even plus odd, we get an odd number. And an odd number doesn't divide 2 to a round number or an integer. Now, some of you guys who watched my NBT videos, I did speak about this, and if you paid attention and not worried about trying to go with the status quo, this question was going to be just, peaches. You just chew upon them and throw away whatever remains, okay? So we know that this has to be an odd number now. So this means from here we can say, well, we appreciate that if we put 3 plus 1, it's a 4. 4 divided by 2 is 2. And that's a whole number. So this will continue as long as n is an odd number greater than 2. So we can say, therefore, n is equal to a set of these numbers starting from 3, 5, 7. If we name 3, the pattern goes on up until infinity. And we know this is the set of values that will, if at all, we put the, it's a set of all the odd numbers starting from 3 to infinity. That's what it is. Because we can see that those numbers, once you add an odd number and another odd number, we get an even number. This is under the principle that odd plus odd gives us an even number. So I highlighted this in our NBT video. So if one paid attention there, this was easy, guys. Provided, of course, you watched some videos. I remember that there was one question from the Northwest which needed this, and I highlighted this. It was not clearly defined there. So now if you have been paying attention, trust me, man, this channel alone could have given you a straight A, and even more, A+, which is now getting closer to 100 and even beyond. If there is beyond, okay, there's nothing beyond 100%. So you could only get closer or get to 100. Anyway, guys, you ignore things at your parish. It's not my problem, it's yours. Alright, guys, before I talk until Jesus comes, this is it. We have made the solution. Now, This is great. And remember, it is important to represent this as a set because these are values that go all the way to infinity. It's not just those three. Okay? Be very careful. So be familiar with mathematical notations. Anyway, guys, this is great. So for me, how do we score these 3 marks? Of course, that set is important. We get a mark. This is very important. Of course, you are not going to write what I put there. These things, all these things, guys, is just my interpretation. I'm just trying to show you guys how to work these things through. But this is not what you put down. Once you write this, this is the conclusion. You can play around this in your mind or on your rough work. So we've got 2 marks already. So obviously, guys, I would believe that a bit of gymnastic, this is still arithmetic, to then show this step right here. It's key. That would be the bonus mark. But someone may give you 2 marks for the answer and 1 mark for that because, I mean, it's a baby stuff there, but who cares? We leave it at that, guys. So this is 3 marks for a total of an easy 27 marks. I've just taken you through it nicely so you can appreciate what is important. So please, guys, practice these things and make sure they are in order. You should be fine to get a distinction already in the term 1. Now next, we're going to do sequences and series, which is going to be question 2 and 3 here. And then we will try and sit on this and maybe curate some proper lessons to make you more better in that section, because it is heavily a term 1 section for the maths, as well as Euclidean geometry. I've already given you videos there to get yourself in the groove. Some provinces may include trigonometry, which I've already given you guys. So you should be able to be covered for term 1 entirely once we do sequences and series in the best way that I think is also more effective. Anyway, guys, goodbye. I hope you are learning. I'll see you again next time. Bye-bye.